I hope you kind of enjoyed that short little video on the kicking of an NFL foot. There's some interesting little stats in there. Okay, there's some interesting stats in there. And so now we're going to talk about momentum. Now, there's a lot of complicated stuff in these slides that are beyond the scope of this course, I think. But we'll just talk through it. In other words, momentum. What momentum is? It's a mass times velocity, and this is what makes our rockets fly, because that's what we're doing. You're going to make a rocket, and it's a lot of fun with vinegar and carbon dioxide. You probably have done, or baking soda, basically. You've probably done that before when you were in elementary school and you made the volcano thing. Well, now we're going to pack that thing in with water and vinegar and inside a 2-liter bottle, cork it up, whoosh, fire it up in the air. It's really cool. All right. So we got momentum is equal to mass times velocity. Okay. And here's the deal. Here's the deal with momentum. Hey, have you seen this before? When we change the speeds, there's a net force on something. It changes its speed over time. That's the change in momentum over time. So Newton's second law of motion in terms of momentum. Here's the second law in terms of the net force is equal to the rate of change of the momentum. Okay, so they're linked to one another. All right. If there's no net force acting on a system, its total momentum cannot change. In other words, if all the net force, if all the forces add up to 0 before something happens, then there's a collision, and then something, and then the collision's over. It doesn't last very long. Then the momentum at the end is the same. There are no. So let's take a look. What do we mean? All right. So look at this. What's the momentum of these two blocks right now when they're being held by the spring? Right, it is 0, because the velocity of this, the speed of this, velocity of this block in this direction right now is 0. Velocity of this block in this direction is 0. However, there's a potential energy there with the spring that's ready to do work and to send them off with a constant velocity. Once the spring is relaxed, once we break, we cut that string or burn it with a match, boom, then this block takes off this way. And let's say this block took off this way at 10 meters per second. So you got 1 kilogram times 10 meters per second. So that would be 10 kilogram meters per second. So we've got a momenta of 10, but it's going in a negative direction. So it's negative 10. And then if this is 2 kilograms, then this velocity is 5 meters per second, and it's going positive 10. So you've got negative 10 plus positive 10 is equal to 0. So the momentum of the whole system of the two blocks is still 0, because this is negative 10 and this is positive 10. All right? Again, collisions happen quickly enough, then can be ignored. Then the external forces can be ignored that happened, like when this bullet hit here and it blew up. All right. Therefore, momentum is conserved during a collision. You've probably seen this better if a firecracker moving along, all of a sudden it explodes really fast. If it's traveling along horizontally, it explodes. Well, the firecracker will kind of keep going. The center mass of it will keep going. But bits and pieces will fly off in all kinds of directions. But the different masses, if we add all these up times their velocities, they will all add up to this one. Because the y components, which I'm getting way beyond the scope of the course, because this has a direction that's in the x and y direction. Well, look at this, negative y, positive y. So the y's get canceled out, and we're left with the actual initial velocity, or the actual, well, it'll slow down, but the momentum, this is 0. This has a tremendous amount of momentum. Bust into here. This total momentum equals this total momentum. All right, if I beat that to death, probably need to do one more on our intro to momentum. So what I'd like for you to do, I want you to watch the NFL movie on third law and momentum, and then we'll reconvene and we'll do an intro to rockets based on this principle. All right? And don't be afraid. If you're going, holy crap, this is going to be me. No. Relax. You're going to be fine. Trust me. I'm a doctor. All right?